Hi guys. Alright, we are going to go ahead and do an overview of this thing called the scientific method. So we're going to start talking about how to do experiments in science class. And the scientific method isn't something that is perfect, nor is it something that is actually used by every single scientist, but it is a general guideline for how we do science, and mostly how we'll do science in this class. So the scientific method involves a series of steps that are used to investigate a natural occurrence. That means we see something, we observe something, we ask a question, and we are going to do an experiment to try to figure out what the reason for that natural occurrence is, or whatever the answer to our question is. So the scientific method has several steps. Let's move it down a little bit more. We make an observation or ask a question. We research the information and call on our scientific knowledge. We formulate a hypothesis. We we create a procedure or perform a method for creating the experiment. We collect data through experimentation. We analyze those results. We come to a conclusion, and then we share those results with the people around us. So as I said, the first question was observation or ask a question. So first, we're going to talk about making an observations or asking questions. First, we make an observation that raises a question. So I noticed that, let's see here, my plant is dead, and I'm like, I wonder why my plant is dead. And that asks a question, right? So what caused my plant to die? Now, this question should be able to be answered through experimentation and should show a cause or effect relationship. So I can sit there and say, well, my plant is dead, so I think that, I wonder if it's the amount that I was watering that killed it. So the cause would be the amount of water, and the effect would be the life or death of my plant. Next, we research or call in scientific knowledge. So we research our topic, we call in our own scientific background knowledge, and we organize it into a paragraph to explain everything we know about the topic we're testing. Next, we formulate a hypothesis. This predicts how the cause and effect relationship will work and tells us why. It should be phrased if, then, and because. So an example of that would be, if soil temperatures rise, the plant growth will increase because cells in the roots prefer a mild environment. So you see the if, it tells us what we're doing, then it tells us what will happen to whatever we're testing, so the effect, and then it will tell us why we think that based on our research or scientific knowledge. Next is the procedure or method. So we're going to develop a procedure for how we will do the experiment. This will include a list of materials, which also includes safety materials. We have to always include those that we're going to need to complete the experiment. We're going to identify all the different variables as well as the number of trials or times we repeat it that we will use. Next, we're going to collect our data, and we do this actually by following our procedure. Okay, so we do our experiment according to the procedure. Then we're going to input quantitative data into data tables if we get quantitative data. Remember, quantitative is with numbers. Or if we are getting qualitative data, okay, it should be very descriptive if it's written, or the pictures should be very colorful and include labels so we know what we're looking at. Oops. Analyze results. So when we are done collecting all of our results, we're going to calculate averages if there's quantitative data, means, medians, modes, in order to look at trends or patterns in the data. And then we're going to create a graph or graphic to easily represent and interpret the data. Then we're going to make a conclusion. So this is basically a summary of the experiment that includes a restatement of our purpose or question and a statement that explains whether the data supports or rejects our hypothesis. Okay, it also makes recommendations for further study and possible improvements for the procedure. We then communicate our results. So we should be prepared to present this project or this experiment to an audience of some kind, whether it be written, whether it be a presentation with a PowerPoint or presentation with a poster. We should always expect questions from the audience, so be prepared for that. All right, so now that we have gone over the basics, we're going to go ahead and try to do an example. So this is, okay, John is watching his grandmother bake bread. He asks his grandmother, what makes the bread rise? She explains that yeast releases a gas as it feeds on sugar. John wonders what effect the amount of sugar would have on the size of the bread loaf. So that's his question. He's wondering what effect the amount of sugar has on the size of the bread loaf. So he asks, he's actually going to make a scientific question here. He's saying, how does the amount of sugar used when baking bread affect the size of the bread loaf? So that tells us the cause, which is the amount of sugar, and the effect, the size of the bread loaf. He's then going to do some observation or research or scientific knowledge, and he is going to research the areas of baking and fermentation, and he's going to come up with a way to test his question. He's going to write a nice paragraph that explains it all, and then he's going to formulate his hypothesis. Now that he has some good background information and good research and talk to his teacher, he's going to come up with a hypothesis. And his hypothesis should be phrased if, then, because, like we said. So if more sugar is added, then the bread will rise higher because as yeast eats the sugar, it releases gases that will make the bread increase in size. So again, if more sugar is added, that's what we're changing. Okay, then the bread will rise higher, that's what we're measuring. Because as yeast eats the sugar, it releases gases that make the bread increase in size. So if his hypothesis is correct, we should see that as long as we increase the sugar, the bread will just get bigger and bigger and bigger. So we remember that a hypothesis is an educated guess about the relationship between the independent and dependent variable, or the cause and effect. Don't worry, we're going to define these in the next slide. So procedure of method. So now John has to determine a detailed outline for how he's going to perform his experiment. He has to identify the independent and dependent variable for his experiment, and he has to identify the control group and the constants. Also, the control group is also called the control, or controls. So the independent variable or manipulated variable is the part of an experiment that is intentionally changed by the scientist. This is also considered to be the cause of whatever's happening, the cause. Okay? There should be only one independent variable per experiment. That's because if we change more than one thing, we're not going to be sure what is causing the effect that we're seeing. It could be multiple causes. If you have multiple causes, then it's going to be multiple causes, and you won't be able to say, well, cause one did this, if you have several causes that all could have did this. So what is the cause of this experiment in our example? The amount of sugar. That is what he's using. That's what's causing the effect. So the amount of sugar that he's using. So for this experiment, John is going to use 25 grams, 50 grams, 100 grams, 250 grams, 500 grams of sugar for each piece of bread or each loaf of bread that he bakes. So the dependent variable. The dependent variable is the effect. It's the thing we measure the change of because of the independent variable. So the cause will make the dependent variable change in some way, and we measure that change, usually with a tool or instrument. So what is the effect in this experiment? The size of the bread. That's what we're measuring. How big is the bread going to be? And how big is the bread going to be because of how much sugar we put in it? And remember, the amount of sugar was the cause. So control. This is the other type of variable. In a scientific experiment, the control is the group that serves as a standard of comparison. So basically, it's the group that is treated as it normally would be treated. So in this case, the example, the control is going to be, all experiments should have a control group or a control. And in this experiment, because John's grandmother always uses 50 grams when baking her bread, John is going to use 50 grams as his control group because that's how it normally would be when the bread is baked. Constants, these are all the other factors. So if you remember, I said there should only be one thing that changes, or one independent variable, one cause. Now, all of the rest of the things that could have an effect on the dependent variable need to stay the same, and those are the constants. So all the factors in the experiment that stay the same. They stay constant, so there is only one independent variable, and so that any observed changes in the bread, so any growth or shrinking in the size of the bread, can be attributed to the change in the amount of sugar, or the independent variable. Examples in this experiment might include the bread recipe. So he needs to use the same recipe every time he bakes bread, otherwise he's not going to be sure if it's the amount of sugar he's using or if just different bread recipes give us different sized bread loaves. The oven used, he needs to make sure that the oven he uses is the same, or he's not going to be sure if the size of the bread is because of the oven, maybe it got hotter, maybe it didn't get hotter. And he's not going to be sure if the cause of the bread getting bigger or getting smaller is the amount of sugar. He's going to think it could also be the oven. So we have to keep the oven the same. We have to keep the rise time the same, the brands of ingredients the same, the cooking time, the type of pan used, the air temperature, the humidity where the bread was rising, the oven temperature, and the age of the yeast. These are all examples of constants. Things that need to be kept the same so that we can assure we're determining a cause and effect relationship between our independent and dependent variable. Trials. Trials refers to the number of times we perform each set of conditions. So that means if we're going to choose 3 times, that means that he's going to bake a loaf of bread with 50 grams of sugar 3 times. So he'll end up baking 3 loaves of bread, each which use 50 grams of sugar. Then he'll bake 3 more loaves of bread, each that will use 100 grams of sugar, or all of the levels of independent variables that we spoke about before. Then he's going to collect his data. He's going to come up with a data table that he can record his data in, and he's going to get all his materials together and actually perform the experiment. Finally, he's going to analyze that data. He's going to calculate his averages because he has more than one trial in each situation, and he is going to look for patterns. He's going to notice that, or he does notice that the control works the best in his experiment, but not significantly better than 100 grams of sugar. So he's going to form a conclusion, and his conclusion is going to be that his data did not support his hypothesis, which, if you remember, was that the more sugar that you add, the bigger the bread will get. And because of that, he knows that's not true. He did his experiment. He saw that 50 grams works the best, and 100 grams was in second place, but the 250 grams and the 500 grams did not work nearly as well, and the amounts under 50 did not work nearly as well. So it did not support his hypothesis. Now he's going to ask a new question, which is, let's look at specifically the amounts of sugar between 50 grams and 100 grams in order to determine what the optimum amount of sugar to use in bread is. All right, so then he would share his data, guys. So essentially, the very last thing you do is you share your data out with your class and you say, this is what I found, or out with the community, this is what I found, and this is the important piece of it. So, all right, that is the scientific method, or at least a brief overview. We are going to be continuing to practice this and practice this and practice this, so get ready. All right, thank you.